Hi everyone, in this video we are going to practice doing a few simple calculations with the mole. So let's start off with something very simple. Like I said, how many pennies are in 1 mole of pennies? Go. So hopefully right away you were able to say, oh, I know that. That is definitely 6.02 times 10 to the 23rd pennies. Now, if that wasn't the first thing that popped into your head, that just means that we have one little vocabulary thing that we need to kind of bring together. So when I ever say a marathon, you're going to say, 26.2. If I say a century, you think of 100. If I think of a year, you think of 12 months. If I think of a dozen, you say 12. When I say a mole, you need to be thinking 6.02 times 10 to the 23rd. That just needs to be what you're thinking. So 1 mole is equal to 6.02 times 10 to the 23rd. What's 2 moles? Did you get it? Hopefully you did. So all you had to do is take 6.02 times 10 to the 23rd, because that's how many pennies are in 1 mole. And now we're saying, oh, we have 2 moles. So you just multiply that number by 2. If you did that properly, you would get something like 1.204 times 10 to the 24th pennies. Okay, so something very simple, but we just need to get that straight in our head that 1 mole is 6.02 times 10 to the 23rd of whatever it is. We keep talking about donuts, bikes, chairs, whatever it is, or molecules for that matter, and it just means 6.02 times 10 to the 23rd. All right, so now let's actually use that number to do something that's helpful for us. And so a lot of times we use that to do, or to calculate what's called the molar mass. So what is the molar mass of methane, CH4? So the first thing that you have to do for this problem is you need to break this molecule apart. So the first thing that I see is that there's 1 carbon, so we need to get the atomic mass of 1 carbon, which is about 12.01 grams, and then we see that we have 1 carbon, so we're just going to multiply that by 1, nothing fancy, but it's more of a bookkeeping thing or a note-keeping thing, so I always encourage you to do that. Then we can do the same thing for hydrogen. We can see off the periodic table that hydrogen has an atomic mass of 1.01, and that's a gram, but there's 4 hydrogens, so we're going to multiply that by 4. So 12 times 1 gives us 12.01 grams, and then 4 times 1.01 gives us 4.04 grams. So now in order to determine the molar mass, we just take these two terms and add them together. So 12 plus 4 gives us something close to about 16.05 grams. And now this is a molar mass, so we're saying the mass, that's the gram component that 1 mole weighs. So this would be 16.05 grams per every 1 mole. Very simple. Let's ramp it up. What is the molar mass of barium hydroxide? All right, did you get an answer? Hopefully you did. This was a little bit more complicated because you had to be able to kind of identify the fact that we are dealing with barium and a hydroxide component, but that 2 distributes to both the hydrogen and the oxygen. But hopefully that was clear in your head, so let's just see. So the barium component is what we start with first. Barium has an atomic mass of about 137.3 grams per every 1 mole. Then we can look at oxygen. Again, we had only 1 atom of barium. Now we can look at oxygen. Oxygen is about 15.99 grams per every 1 mole, but we have 2 oxygens, okay, we know that because of the 2 has been redistributed. Same thing for our hydrogen. Hydrogen has an atomic mass of about 1.01 gram per every 1 mole, but we have 2 different hydrogens in this, so we need to multiply those all together. So we end up with something close to about 2.02 grams, something close to about 32, so 31.98 grams here, and then just multiplying that 1 gives us 137.3 grams. Now, for molar mass again, what we have to do is add all 3 of these terms together, and if you can punch those into a calculator properly, you would get something like 171.3 grams per every 1 mole. Remember, this is the mass per every 1 mole. All right, so now, if you fully understand this, you can answer this next question. What mass in grams does 6.02 times 10 to the 23rd xenon atoms weigh? Go. Did you get it? Oh, please tell me you did it. I hope you did. I hope you did. If you got the answer of 131.3 grams, then you are absolutely correct, which means you fully understand this. So what I'm telling you to do is to go to the periodic table and find xenon. Now, we know that 1 mole is always equivalent to 6.02 times 10 to the 23rd atoms. And so if we're asking for what the mass is of 1 mole, all you had to do is figure out what the atomic mass is of xenon, and you can do that just from the periodic table. And if you did that properly, you'd get an answer of 131.3 grams. Have a great week. Take care of yourself and drink water.